Hello and welcome to the 45th Great Lakes Phragmites Collaborative webinar as part of our Students of Phrag webinar series. My name is Sam Tank and I'm from the Great Lakes Commission, and I'll be hosting this webinar today on behalf of the Great Lakes Phragmites Collaborative. So our presenter today is Verena Sesin, and she is from Trent University. And we are very excited to have her as she has been doing some really great research as part of her PhD on the risks of glyphosate herbicide-based Phragmites management on native and endangered plants. Before I turn it over to Verena, though, I do want to tell you a little bit more about the Great Lakes Phragmites Collaborative and the work that we do. The collaborative is a partnership to link people, information, and action on all things invasive Phragmites. It is jointly coordinated by the Great Lakes Commission and the USGS Great Lakes Science Center. We're both located in Ann Arbor, Michigan. However, we do serve all 8 Great Lakes states and Ontario and Quebec as well. And we do have funding from the Great Lakes Restoration Initiative. The collaborative is meant to facilitate communication among stakeholders from across the region, and we assist in the development of management tools and programs and serve as this resource center for Phragmites biology, management, research, restoration, et cetera, et cetera. The collaborative is led by a multi-agency advisory committee, and we use the principles of collective impact to advance our common agenda for Phragmites management throughout the Great Lakes region. If you're interested in checking out our common agenda or some of the resources that we have, you can visit us at www.greatlakesphragmites.net, or you can always reach out to us at phragmites@glc.org. A big component of the work that we do at the collaborative, and one of the ways that we engage with Phragmites professionals throughout the region, is through the Phragmites Adaptive Management Framework, or PAMF. And what PAMF is it's a participatory science program that provides data-driven Phragmites management guidance through an adaptive management framework. And what this means is that we have established a way to learn from what Phragmites managers are doing and turn that into annual guidance to help managers make effective and efficient management decisions. So anyone on this call who is in the Great Lakes region and is managing Phragmites or hoping to manage Phragmites in the future, we'd really encourage you to get involved, and you can learn more on our website, or you can email us at pamf@glc.org. Anyone interested in joining PAMF and taking advantage of our guidance, you can enroll management units anytime. If you do it before the end of the month, then you're going to be eligible to receive guidance in August for the 2021-2022 PAMF cycle. We have lots of training resources to help you get started. If you want to learn more, again, visit our website or shoot us an email. The collaborative does a lot more than just PAMF. If you're interested in learning more about some of the work of the collaborative, you can visit our website and check out all of our different resources, including different management guidance and recordings of past webinars. You can also join our listserv and connect with, I think it's close to 800 different professionals from across the region and beyond, and also sign up for our bi-weekly newsletter, which I'm sure many of you are on it, and a special treat is always our fake Phrag headline. So if you don't know what I'm talking about, sign up, and I'm sure you'll be amused, just like we are, as we're giggling behind our computers as we create them. If you sign up for the newsletter, then you'll also receive the quarterly research roundup, which consists of academic papers that have been published in the past 3 months, and that goes out. That just went out actually earlier this month. And you can also find links to lots of other resources from external sites as well. And again, that link is greatlakesphragmites.net. Today's webinar is going to be recorded and uploaded to our YouTube channel and our website. And you can access an archive of past presentations on the website as well. This is the 45th webinar, so there's lots of other webinars and lots of other information that is going to be available to you. And hello to all of you watching in the future. If you're watching the recording, please feel free to share this information with your colleagues, and don't hesitate to reach out even if it's long after the presentation date. And finally, you can connect with us on our social media accounts. So feel free to tag us at GL-Phrag on Twitter, Instagram, and Facebook. To help our webinar run smoothly today, I just want to go over a few technical reminders. Audio for this webinar can be streamed through your computer or through your telephone if that's easier. And then if you are able just to mute yourself and turn off your camera, that's going to save on bandwidth and limit any background noise as well. Since the chat seems to not necessarily be working for everyone, we will be able to use the raise hand feature. But if you are having any sort of technical issues and you can't send us a message through the chat, just go ahead and shoot an email to phragmites@glc.org and Patrick will be monitoring that. And I do have the raise hand feature X'd out, but when it comes to question and answer period at the end, if you do want to raise your hand, if you're not able to access the chat box, feel free and I can unmute you and then allow you to ask your question. Otherwise, I'll facilitate a question answer period at the end, but feel free to put in questions along the way as you have them, and I will keep a list. Okay, enough of housekeeping now. It is my great pleasure to introduce our presenter. She comes from Trent University. Verena Sesin is a PhD candidate in the Environmental and Life Sciences program at Trent University. And her research interest lies in pesticide effects and persistence in plants to inform ecological risk assessment. Her goal is to help develop effective management practices for invasive plants and minimize risks to nearby non-target native plants. Verena is also a passionate science communicator, sharing stories through Twitter and blogging, and co-organizing a communicating science workshop for graduate students across North America. Thank you so much for sharing your work with us today, and I will transfer controls over to you, and please take it away.
Thank you so much, everyone. I really appreciate this opportunity to share my research with all of you today. So I'm loading up my presentation, and we get right into it. So today I'll be speaking about the risks of glyphosate herbicide-based Phragmites management on native and endangered plants. And I want you to all think for yourself, the ones of you that have a front yard or backyard or sometimes go out in nature, and you have maybe seen some plants, especially in your backyard or in your vegetable patch, that you don't really want to be there. And we also often call those weeds because you really don't like them. And I know myself, I have a vegetable patch out in my backyard, and I tend to always go there and like pick out all those plants that I don't like. So I want to invite you, if you have access to the chat, just share with everyone else what are the types of plants that you really don't like in your backyard or front yard, and what are you doing about them? So just give you a couple of seconds here to think about that and share with everyone, because I think we all have some of those issues around our house. And if Sam just wants to give a little bit of a roundup of what everyone is sharing, then that would also be appreciated.
Yeah, we're just having some come in. So there's broadleaf plantain, and Tracy doesn't know how to control it. And there's, strangling dog vine and uses spray and digging that out. Creeping Charlie, that one is all over my yard as well too, and hand pulling for that. Black swallowwort, lots of different unwanted plants. Mint, yeah. That's a hard one. Garlic mustard, make pesto out of it.
Great suggestion. Thank you for sharing. So I see really lots of you as well are dealing with similar issues like myself in my backyard. And often, especially if it's like smaller plants, we're just having them on our property, we might have a chance to just control them by ripping them out, just like on this picture. I get my gardening gloves on and then I just pick out those plants by hand. However, that's not always possible if the invasive plants look like this. And it's like you can't just come with a glove on and rip them out. It would be illusionary. And here's another picture just showing the extent of how some of these plants can grow so densely and tall that we really can't get a handle on it. And this is when we call them invasive plants, really. It's alien invasive species whose introduction or spread negatively impact the environment, economy, and our society, including our health, and especially our backyards as well, where we just want to grow some vegetables. Globally, there are many of these invasive plant species, over 450 ones. And here you can just see a couple of pictures of invasive plant species we have here in Ontario, where I'm currently located. I'm located near Toronto, and we're also dealing with many of these invasive plant species here. And the reason why we're often concerned about those is because before the invasive species come in, we have ecosystems that are quite diverse. You can see on the left picture here, a variety of different plant species. We have some submerged species, floating species, emerging species. And then on the right, we can see a monoculture of an invasive plant. And in this transition, we're losing some of the habitat structure. Everything is homogenizing to one invasive plant species, which can sometimes result in not so many animals as well being able to use that ecosystem anymore. Invasive plants can alter ecosystem functioning, and they can overall reduce diversity of plants because they're simply taking over and displacing many other native species. So ecosystem managers are quite concerned about those invasive plants. And as many of you in this talk are familiar with, I suppose, Phragmites australis has been called Canada's worst invasive plant, and is really a bad invasive plant among many others as well, because it spreads very quickly. It grows tall, it grows densely, it can take over those ecosystems because it grows so quick and tall that it can displace native species that simply don't keep up with it. So it can outcompete native plants and thereby eventually form those large monocultures that we have seen on previous pictures. So one option to get ahead of the spread of invasive plants, such as Phragmites, is to use glyphosate herbicide. Glyphosate herbicide is a chemical that is designed to kill plants, especially invasive plants. It's really useful for those. And it's useful for those because it has two key properties. First of all, it is non-selective, meaning that it is toxic to a variety of plants. So it's a really convenient control agent in the fight of invasive plants because it's toxic to many. So you can grab it and you can kill a whole different bunch of invasive species with it. It's also systemic, meaning that if it touches the plant leaves, it can translocate throughout the plant into the roots and rhizomes and really kill the whole plant. So it's convenient for control of some of the harder to control perennial species as well, with those large underground structures. However, because glyphosate is so systemic and convenient and toxic to many plants, there is also the risk that it could potentially harm native species that are growing nearby. And this is some of the key aspects I'm looking at in my own PhD thesis. And here's just a graphical representation of some of the research that I've been doing. So I'm addressing the scenario that if we spray glyphosate herbicide on invasive plants, here on the left you can see the graphic, then I'm thinking some of that spray could also reach native plants nearby, but as well, all of the different invasive species could respond differently to the spray. So it's about finding out what are the effects of glyphosate spray on different species. And then as well, if we spray it on those plants, could glyphosate get accumulated in those plant tissues, so in the leaves that we're spraying with it? And if it gets accumulated, moving on to number 2 here, can this decomposing litter from the toxic effects potentially release some of that glyphosate again later into surrounding water that could emerge in the vicinity of invasive plant litter? And then as well, looking at third point here, spray is one way to control it, and one way that also native plants could be exposed to it if they're growing nearby it. So there could be spray drift happening during application that could reach nearby native plants. But native plants can also be exposed through other ways. For example, those low-level water residues that might come from applications nearby. And as well, glyphosate is not only sprayed on invasive plants, it could also be applied by wick application, so touching the invasive plants with a cloth or a glove that is submerged in glyphosate solution. And then glyphosate could potentially also transfer into the rhizosphere soil that is surrounding those invasive plants, thereby potentially expose nearby native plants. So looking at this whole pathway, this is what I want to talk to you about today. And we're starting with the first point, the variation in glyphosate sensitivity among invasive and native plants. But before we get into those weeds, I just want to say a huge thank you to everyone who supported this project, because I could, of course, not have done it by myself. Special thanks to my supervisors, Joanna Freeland at Trent University, Christina Davey of the Ontario Ministry of Natural Resources and Forestry, and my collaborators, Kevin Stevens, Rebecca Ham, Janice Gilbert, and lots of technical assistance from students and researchers at Trent University. So diving right into the first question here, how much do invasive and native plants vary in their sensitivity to glyphosate? And I wanted to compare the sensitivity among two invasive plants, Phragmites australis, our well-known invasive plant here, and also another invasive plant, which is quite common across North America now as well, the invasive cattail, Typha exglauca. And to look if there's any differences between invasive and native plants, I also looked at Typha latifolia and native species in North America. To answer this question, I built up some micro-wetlands in the Trent University Research Garden, and I performed a dose-response study, applying different doses and observing the response. Each of those blue tubs is one micro-wetland. And as you can see in the graphic on the top right corner, each micro-wetland contains 3 plants, one of each of the 3 species as introduced before. They are grown in sediment and submerged in water to imitate wetland conditions. Then I applied a range of different glyphosate concentrations on those wetlands, imitating spray in natural areas. The range from glyphosate ranges from 0.1% up to 8%. And the 5% solution is actually the concentration that is currently used in Ontario to control invasive Phragmites. We also use the 0%, which is just tap water soil control treatment for our study. Here you can see a picture of me spraying those micro-wetlands with the different solutions. That's me in the blue suit, and I'm imitating the spray that would happen on Phragmites. We wrapped all those micro-wetlands in this plastic wrap, as you can see in the picture, because we didn't want to go any spray drift on neighboring wetlands. 7 days after spraying the plants, we assessed how sensitive are the plants to glyphosate. For that, I first counted the total number of plant shoots, then I counted the number of dead plant shoots, then I calculated the proportion of dead shoots, and I used this endpoint to use dose response modeling and derive an LC50 value. LC50 is 50% of the plant population, and this value is often used to compare sensitivity among different plant species. So let's look at what I found. Here are some pictures of representative replicates of those micro-wetlands on day 4, 11, and 27 of 3 different treatments, the control treatment, so plants sprayed with tap water, 5% glyphosate, and 8% glyphosate. As you can see from those pictures, I observed toxic effects from glyphosate after a few days at all applied concentration. You can see those plants here really yellowing and then fully dying off and just being brown and crumbly, dying off from those toxic effects from glyphosate. The severity of effects increased with time and also with the applied concentration. Seeing the effects so visibly, I wanted to see what is the actual sensitivity of those plants to glyphosate. Here on those graphs, you can see 3 panels, the top Phragmites australis, then Typha latifolia, and Typha exglauca on the bottom. For each plant, the proportion of dead shoots that are counted against the x-axis glyphosate concentration applied on the plants. Those curves are the dose-response relationships that I modeled, with the red dots being the LC50 values. So to remind you also, LC50, the concentration that is lethal to 50% of the plant population, and the lower the LC50, it means the more sensitive the plant. So let's look at those values for the LC50. You can see Phragmites australis 0.34, Typha latifolia 1.37, and Typha exglauca 1.7. And from this data, I can see that Phragmites australis has 4 to 5 times higher glyphosate glyphosate sensitivity compared to the Typha species, the LC50 is much lower. However, there was no difference between Typha species. Here the LC50 and the confidence intervals overlap. I also observed above ground mortality of 97% for Phragmites and 87% for Typha X glauca sprayed with the 5% glyphosate dose, which is commonly used for Phragmites control in Ontario. So from this, I conclude that Phragmites australis is much more sensitive than Typha X glauca, and both Typha species, invasive and native, are similar in their response. Which brings me to my recommendation using those findings to really consider, if we're managing Phragmites, the species-specific sensitivity of those plants to glyphosate. We saw that Phragmites was much more sensitive than Typha X glauca, so probably we don't need as much of a high rate for Phragmites than we would need for Typha X glauca to control it. Typha X glauca and the native Typha latifolia being similarly sensitive, it's important to consider if we're controlling Typha X glauca, which grows right next to Typha latifolia. They often co-occur, so knowing that it's similarly toxic to both species, we want to be careful for control actions of invasive right next to native species of the Typha genus. Moving on to the second part, glyphosate uptake and retention in treated invasive plants. My question was, can treated plants influence glyphosate fate through retention and release? And I answered this question with two invasive species, Phragmites australis and Typha X glauca. In order to quantify glyphosate uptake, I again used our micro-wetland study, and I harvested plant material at 27 days after spraying the plants. I harvested material from Phragmites and Typha X glauca and quantified glyphosate in the leaves and stems from those plants that were treated with either a 5% or an 8% glyphosate solution. Let's have a look at what I found. Here on those graphs, you can see the glyphosate present in plant tissues for both of our species, invasive Phragmites, invasive Typha here on the bottom, at both applied glyphosate concentrations, 5 and 8%, as you can see on the top. And from this data, you can see that invasive Phragmites takes up much more glyphosate than Typha X glauca at both of the applied concentrations, 5 and 8%, which is not surprising because it was also more sensitive to it. Now that I know that glyphosate can be accumulated in plant tissues, I wanted to know, can glyphosate also be released again from plant tissues? So I performed a glyphosate release study. I used the plant material that I harvested, and that was either treated with 5 or 8% glyphosate, and submerged it in those buckets of water. So you can see me here in the greenhouse setting up mini buckets and submerging plant material in them. And then I let it sit and leach glyphosate. And I sampled this leachate over the course of 21 days at 5 different time points. 1 hour after putting the plant material in the buckets, 1 day, 3 days, 7 days, and 21 days after introducing the plant material in the water. Let's have a look at what I found in terms of glyphosate released from plants. On these panels, you can see the total glyphosate released over the course of 21 days for both invasive species, Phragmites and Typha X glauca. First of all, I can see that both plants release glyphosate from their plant tissues. We detected glyphosate in the leachate as soon as 1 hour after introducing it into the buckets. We can also see that invasive Phragmites leached more glyphosate than invasive Typha X glauca at both concentrations. This is also interesting because I found that invasive Phragmites accumulated more glyphosate than Typha X glauca. To answer my question, can treated plants influence glyphosate fate through retention and release? I have a check mark here because yes, I found that treated plants can uptake and release glyphosate from their tissues. This brings me to my recommendation for glyphosate-based Phragmites control, to be aware of treated plants' ability to act as sink and source of glyphosate. As we can see in those pictures, they're often managed on a broader scale, and we have to keep in mind that all of this plant material that is sometimes rolled or left standing after treatment could potentially accumulate glyphosate and release it many, many weeks later. Now I'm diving into the third part of my talk, effects of incidental glyphosate exposure to native plants. I'm addressing the question, are native plants at risk from nearby glyphosate applications? And I'm using two native endangered plants in Ontario, Sida hermaphrodita and Amania robusta. Sida hermaphrodita is also called Virginia mallow, and Amania robusta is scarlet amania. And both of these plants are threatened by Phragmites. Phragmites threatens to outcompete these plants in their habitat and also reduce suitable habitat for each of those. So it's important to be aware of this threat when we plan recovery actions. And I wanted to know, are those plants potentially at risk not only from Phragmites, but also from glyphosate applications on Phragmites? So I looked at three potential relevant exposure pathways of those native plants. First, spray drift from nearby applications. Second, low-level glyphosate residues that could be present in the water from nearby applications. And lastly, adjacent big application on invasive plants. Is there any potential effects on native plants? For spray drift, I used, again, a dose response study with a range of glyphosate concentrations up until the 5% commonly used rate for Phragmites control in Ontario. And I did this experiment with both species, Amania on the left, Sida on the right, that are exposed to glyphosate spray drift. For water residues, I used Amania and two different glyphosate concentrations that were detected in Ontario surface waters, 2 micrograms per liter and 41 micrograms per liter. And as you can see in this picture, there's some water under the pot of the Amania. This is where I replaced the tap water with either of those low glyphosate concentrations for pulse or continuous exposure, so just short exposure, and continuous meaning constantly exposed to glyphosate solutions in the water to see if there's any effects of those low-level water residues on the plant growth. And lastly, for adjacent big application, as you can see on the right here, on the right top picture, you can see an Amania plant growing next to invasive cattail in one pot. So simulating that they're growing right next to each other, and then what happens if we wick apply glyphosate on the invasive plant. On the bottom right, you can see a video of me that is hopefully. You can see me wicking this glyphosate on the invasive cattail. So this glove, the green one, is submerged in glyphosate solution and then wicking it on the invasive plant. So it's a very targeted application method in comparison to spray. Let's look at some of the measures I took to infer the sensitivity of the plants. So 14 days after each application method and for each pathway, I measured how the plants are responding. For Sida hermaphrodita, I measured 6 different growth-related endpoints: main shoot length, total surface area, healthy surface area, dry shoot weight, percent dry matter, and root dry weight. For Amania robusta as well, I measured 6 different endpoints that are just slightly different depending on its morphology. So here I measured main shoot length, total shoot length, number of side shoots, shoot dry weight, percent dry matter, and root dry weight. Let's see how the plants responded. First, glyphosate spray drift. Here you can see some pictures of our 2 different plant species, representative replicates for each of our glyphosate spray concentration treatments. From 0 is just a control treatment, so they were sprayed with tap water, up until 5% glyphosate. And as you can see, as the red lines indicate as well, I detected some toxic effects of glyphosate spray drift on these plants. I also calculated the EC50 values, so those are the concentrations that have an effect on 50% of the plant population. And here I'm just putting in the ranges. Here are the ranges because I measured those 6 different growth endpoints. So for each of those, you can also get an EC50. And we can see, similar as we said earlier, the lower the EC50, the more sensitive the plant. So comparing those ranges, I can see that Amania is more sensitive than Sida, but both plants were also severely affected at concentrations above 1.34% glyphosate. If you look at those 2 plants at 1.34 and even at 5% glyphosate, they were really, really crumbly and dead and probably not able to recover from this spray drift anymore. Interestingly, I also detected evidence of hormesis in Sida. You might have already seen it on the previous pictures as well, that plants around the middle of this concentration rate, so about 0.1% glyphosate spray, they were growing quite well and they responded almost positively to the spray treatment. So hormesis means that at higher concentrations, there is this inhibiting effect on growth, but at lower concentrations, there can be a stimulating effect on growth. And in my research, I detected that Sida has this hormetic response to glyphosate spray drift, where at those low concentrations, its growth is actually stimulated. And I found the stimulation up into 137% compared to the control of 100%. And I detected this hormetic effect for 4 of the 6 growth endpoints that are measured for this plant, which I thought was really exciting and interesting. Now switching over to the water surface residues. So here you can see representative replicates of our 5 treatments. So first on the left, the tap water control, so ammonia grown just in tap water. Then we have 2 pulse exposures of 2 and 41 micrograms per liter glyphosate in the water. Pulse means I put the glyphosate solutions in there from day 1, but then up until day 14 of the experiment, I just replaced it and topped it up with tap water. Whereas for the continuous treatments, I continuously filled this dish with glyphosate solutions. As you can see from the plants, having a look at them, they all look quite happy though. And this is what I found as well. I did not find any negative effects of those low-level glyphosate surface water residues on the ammonia plant. Moving on to the third exposure pathway, adjacent glyphosate wick application. Here we can see on the left an ammonia plant just growing by itself in a pot. Then on the middle, ammonia plant growing next to an invasive cattail, which was not treated with glyphosate. And then on the right, ammonia grown next to invasive cattail, which was treated with 5% glyphosate with a wick application. And as you can see from all those ammonia plants, they look quite happy. And this is what I found as well. I did not find any negative effects on ammonia from adjacent glyphosate wick on the invasive plant, which was great news. So coming back to the question, are native plants at risk from nearby glyphosate applications? I found that glyphosate spray drift can impair native species growth, but there was no evidence of effects from water residues or adjacent wick application. Which brings me to my recommendation for glyphosate-based Phragmites control, to use application methods that are least harmful to nearby plants. And I know that wick application might not always be feasible because it's quite labor intensive, but it is targeted. So whenever it's possible and there's invasive plants growing next to native endangered plants, it might be worthwhile considering a wicking application instead of a spray to really target the glyphosate on the invasive plant and reduce impacts on the native endangered plants. So to summarize the whole talk, what we've learned today. First of all, here number 1, looking at glyphosate sensitivity of different invasive and native plants. I found that there were species-specific differences of those plants in their response to glyphosate spray. Invasive Phragmites was much more sensitive than invasive cattail. Both cattail species responded similarly. I found here under number 2 that invasive plants can uptake glyphosate and they can also release it later into the water phase. And under number 3, I found that there's relative differences in risk to native plants from different exposure pathways, finding that spray drift could be a potential risk to native endangered plants, whereas I found no evidence of negative impacts from low-level water residues and adjacent wick application. To summarize my recommendations again, I recommend to consider species-specific sensitivity, to be aware of treated plants' ability to act as a single source of glyphosate, and to use application methods that are least harmful to nearby native plants. Thank you so much for joining today and listening, and here's my contact information. If you have any questions beyond this webinar, feel free to contact me and I'd be happy to chat more with you. Thank you so much.
Thank you. I'm sure we're all giving a big round of applause in our various homes or offices if we're back there yet. Thank you so much for that great presentation. Any questions that you have, you can either tap that or type them in our chat box or use the raise hand feature. We do have some time left for questions. Do have one comment. Wicking is not an approved method for glyphosate in Canada as it's prohibited by the label.
Yeah, thank you for this comment. Yeah, hand wicking, actually, the label has changed, as I believe, a couple of years ago, which actually happened after this study was performed. But yeah, I think though those results are still valid for other wick type applications, such as potentially rope wick or with other methods of application that do not involve the actual hand directly. But yeah, it certainly is an application method that I think would be good to consider, maybe even if the future, if there's any way to introduce it again next to endangered plants.
And what was the timeline for when you were submerging your plant material that had uptake the glyphosate and the time that it was releasing it? What timeline did you look at as part of your study?
Thanks for this question. So I sprayed the plants, and then it was 9 weeks until I harvested them, and then I submerged them for 21 days in the water. So these time frames are chosen based on what we think could happen in the real world. Of course, it was an experimental study, but we wanted to find that extended time frame. So before I harvested that plant material, it rained a couple of times. They were standing outside, so really imitating what would happen and how much glyphosate could be still in there when those plants are left standing for multiple weeks. And then we submerged it for 21 days to simulate plant litter that could be just lying around, potentially submerged later on. So I'd be happy to answer more questions about the timeline and specifics if there's any follow-up questions.
About the concentrations, are the concentrations given for the active ingredient or the herbicide formulation that you're using?
Good question. Those are for the herbicide formulation that I was using, but the related papers are also giving a lot of details on the actual active ingredient formulation. So I'd be happy to forward them to everyone that is interested. So feel free to email me, and I'd be happy to forward those details to you as well.
And I will include your email if that's okay in the follow-up email to all participants. So you can reach out directly too. We do have a couple more questions that are coming in. Did you use a wetland approved version of glyphosate like Rodeo? And do you think that the specific formulation would make a difference to the results you are seeing?
That's a good question as well. For my research, I used Roundup Weathermax, which is not approved over water use in Canada. And so my goal was to imitate the situation that is happening currently where Phragmites is controlled in some ditches and different places where there's no standing water at the time of application. But knowing that Phragmites and other invasive plants as well, especially if they're macrophytes, there will have to be some sort of water input or temporary standing water at some point throughout the year. So we imitated those situations where potentially later there could be some submergence of litter happening as well. But then I recognize that Roundup Weathermax, of course, is not approved for using over wetlands where standing water is present in application. In terms of different formulations, I do think there might be some differences just because those formulations contain also different secondary ingredients or formulants. So it's not only glyphosate in there, it's also different other surfactants and different other chemicals. However, we don't always know what exactly is in there. We try to contact the manufacturer, and it's always difficult to get this kind of information. So that's why we didn't make many inferences about the surfactants and additives. But I think the general conclusions in terms of glyphosate formulation, its effects, are still valid, even if we're using one formulation.
So you mentioned that your concentration of glyphosate detected in some Ontario waters guided the concentrations used in the residual portion of the experiment. Can you say again what those detected concentrations were and if they were in close proximity to a treatment area?
Yeah, those concentrations were 2 and 41 micrograms per liter. I did get those concentrations from the literature, so I would have to look back into those studies to know the exact timing and proximity to applications. So I unfortunately don't have that information.
And then, oh, a hand just went down, but I do believe we had one participant, Ray, raise his hand. If you want to unmute yourself and ask a question, feel free. Okay, any other questions? Feel free to raise your hand or type them in the chat box. Okay, great. Any other questions? Like I said, we will be sending out Verena's contact information. So thank you so much again for sharing your work with us today. And it was really exciting to hear about. And if you have any questions for us at the collaborative, you can always reach out to us at Phragmites@glc.org. This webinar has been recorded and it is going to be available up on our website at under the resources tab under webinars, and it will be on our YouTube channel as well. We don't have any upcoming webinars planned. However, if you are interested in presenting some of your work or you have suggestions, please let us know. Right now, we're particularly interested in hearing from people who have done some Phragmites management and restoration work, particularly surrounding wild rice, and any long-term project updates from long-term Phragmites management efforts across the region and throughout North America. So thank you again for watching, and I just want to once again acknowledge the support from the U.S. Geological Survey and the Great Lakes Restoration Initiative. Thanks everyone, and have a great rest of your day.